My goal in this podcast is over a few minutes to convince you as to the need to use units and calculations, and not just because I told you to do it. So let's try a few. What, 60 minutes per hour. 60 and 60 is 120. That's 30 minutes less, which is half an hour. Okay, 2.5 hours. And look, I did it in my head, didn't show my units there. I didn't prove my point, did I? Let's try another one. 12 inches per foot. 5 times 12 is 60. So it's a little more than 5 feet. Okay, I'm not making a very convincing argument for using units, am I? Let's try another one. How many milliliters are in 1.20 liters? 1,000 milliliters per liter. 0.2 of a liter, which would be 200 more milliliters. Okay, 1,200 milliliters. There, I did 3 problems. Didn't show my units. Didn't show my work. Poof, the answer. And all of them have reasonable conceptual checks, too. You can look at the answer and see if it makes sense. Like on the first one, if I would have come up with, 15 hours, hopefully you would have figured out that that was wrong, just because it was 15 hours. Okay, let's try another one. Here, get some paper out, get a pencil out, calculator. And then I'll read it, give you some time to work on it, about the same time I gave you on the other ones. You have a 73.5 kilogram patient who requires a dopamine IV infusion rate of 5 micrograms per kilogram per minute. If the IV contains 800 milligrams dopamine in 250 milliliter solution, at what infusion rate in milliliters per hour should the pump be set? Are you done? Good. And obviously you got 6.89 milliliters per hour, right? Say what? Yeah, this is a hard problem. This is not one that you can do in your head. There is a tremendous amount of information in it. Geez, how do you even set it up? Well, you could set up the problem this way. Now, I'm not going to go through the pieces on that, because that's not the point of this podcast. You will learn to do a calculation like that. I don't mean we're going to be doing IV calculations, infusion rate calculations. If you're going into nursing, you will learn how to do these. We're going to start off at the beginning with relatively simple problems, and then we'll scale them up. You learn how to set the simple problems up using units, so when you get harder problems, you just continue this idea of doing calculations with units. That's the point of dimensional analysis, analyzing dimensions, or unit analysis, factor label method. They all mean the same thing. Learn how to do it with easier problems, so when you get a complicated problem, you can just keep applying this technique to it. How about a few cases of not paying attention to units? 1999, the Mars Climate Orbiter. So it started a program to insert it into an orbit around Mars, and the instructions caused it to do an orbital insertion that took it too close to the planet, and it disintegrated while it entered the upper atmosphere. And the reason that the trajectory was wrong? Not converting between English or imperial units and metric units. Over $500 million was lost. Years of work from many people lost. Years of potential scientific data lost. Paper was put out. There are any number of papers put out about errors in medicine, but on this one, talking about errors in prescribing medicine, it was conducted over a year in a tertiary care hospital and found that over 17% of the prescribing errors on medicine were due to errors in calculations, putting the decimal place wrong, rate expression, or wrong use of units. Over 17% of the mistakes. Another one in 1998, studied the use of equations. And errors in decimal places, mathematical errors, or just expressing the dose wrong, almost 60% of the errors. And in almost 30% of the cases, the equation was wrong. If you're going into nursing or some other area of medicine, people like me are going to depend upon people like you getting this right. If I'm in the hospital, I don't want you getting this calculation wrong. Now, hopefully what I've done is impressed upon you that you have to use your units and calculations. This is a big part of most general chemistry and introductory chemistry classes, to learn how to do this. But I'll give you another reason. You have to learn it because I told you you have to learn it. Now, obviously, I can only take control over the classes that I'm in control of. But I've been an instructor for over 15 years, and people who don't learn how to use this technique don't pass the class. And it's not because the class is all about units. It's not. It's a big part of the initial portion of the class, and it shows up in lab quite often, and it shows up throughout the class, but the class is not all calculations. But people who, for whatever reason, don't learn the ability to do calculations with units have problems in other areas of the class. So spend the time early on to learn this technique. And in the words of a very famous philosopher, do or do not. There is no try.